Welcome back once again to my channel. So today we're going to be moving on to the next challenge in hacker rank, which has to do with printing loops, titled Printing Pattern Using Loops. But before we start, I'd like to pray. Father, thank you for today. Thank you for an opportunity to stay in. Thank you for understanding who you are. And thank you, Father, Lord, that with every practice we do, we're getting closer and closer to achieving our goals. In Jesus' name, amen. Okay, so now, this is a challenge. And let's read it together. It says, print a pattern of numbers from 1 to n as shown below. Each of the numbers is separated by a single space. Okay, so this is the pattern. The input will contain a single integer n, which ranges from the value 1 to the value 1000. And this is an example of the code being run. So you have a sample input of 2, and then you have a sort of grid, which has the number 2 on the outskirts and then the number 1 on the inside. Then when you come to another example, which is the sample input 5, you have another grid, and you have the 5 being outside, you have 4 being like an inner layer, you have the 3 forming another boundary inner layer, you have the 2 like that. Basically, you get the idea. So now, we're supposed to write a program that does this. So based on the user's input, whatever the user puts in as n, then we're going to print out the corresponding grid of this pattern. Okay, now before we even start, the first thing we need to understand, okay, is based on the knowledge we've gathered so far on the 2 previous lessons. We know about grids, we know about rows and columns, and we know that the way we are printing the patterns is by printing every character on each row before going to the next row. So we are printing row by row. So since we are printing row by row and we are printing for a certain number of columns, it means we need to know the size of the grid we are dealing with for every value of n that is entered, because the size of the grid varies based on the value of n. So let's just do a simple like logic something about that. Now, if the user enters 1, okay, if the user enters 1, all we'll have is a box. If the user enters, okay, no, let me undo that. When the user enters 1, we'll have a result of 1. When the user enters 2, what will be the result? The result will be 2, 2, 2, 2, 1, 2, 2, 2, 2. Now, what is this? This is a 3 by 3 grid. We can call this a 1 by 1 grid, right? When the user enters 3, what do we have? We have 3, 3, 3, 3, 3, 2, 2, 3, 3, 2, 1. Sorry. Okay, I see the error now. It's supposed to be 3, 3, 3, 3, like this, 5 threes. Then 3, 2, 2, 2, 3. Then 3, 2, 1, 2, 3. Then 3, 2, 2, 2, 3. Then 3, 3, 3, 3, 3. That is interesting. And what type of grid is this? 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A 5 by 5 grid. And from here you can see the trend. So based on the trend, we know that a 1 is giving us a 1 by 1 grid, 2 is giving us a 3 by 3 grid, since a square grid, 3 is giving us a 5 by 5 grid. So 4 will give us what? A 7 by 7 grid. So from here, we can see that based on the n, we can calculate our grid size. Let's call it that. We call it grid size. And basically, grid size is equal to a simple equation that translates this into this. which is 2n minus 1. So whatever we put inside as n, we are able to get the grid size. So if n is 2, our grid size will be 2 times 2, which is 4 minus 1, which should be 3. So we can implement that right away. Let's do that right away. So we are going to calculate the grid size. Okay. And since this is a square grid, we don't need to calculate two values because it's the same number. So we can say n's grid size, okay, is equal to 2 times n minus 1. And that is it. We have the grid size now. Okay, amazing. That's great. So now that we have the grid size, let's move on to understanding how to fill this grid. So now we have the grid size. So let's take the 3 by 3 grid as our example, and let's use that to come up with the logic for printing the values within each layer of the grid. Now for the 3 by 3, this is what we have. We have 2, 2, 2, 2, 1, 2, 2, 2, 2. Okay. Now we are able to easily determine this grid size. Perfect. And the next thing is, how do we move through? Okay, how do we move through this every single cell on this grid? That's a simple. We use a for loop. We've done this already. So all we have to do is write a for loop for iterating over the rows. Then within that for loop, you write another for loop for iterating over the columns. So basically you have 2 for loops, and then as one iterates over the rows, the inner one iterates over the column. So when the first one is on row 1, okay, when the first for loop is on row 1, the second for loop will be iterating over this, this, and this till it ends. Then we move on to row 2. Then it comes down here. Then we iterate, and then we fill in the values. So that's how we are going to obtain this grid-like structure. So let's implement that as well. So we are going to have something like this. For nth, I'll call it row equal, let me call it 1, okay. Then I'll say row should be less than or equal to my grid size, okay, because I mean we have the grid size number of rows. We have 7 rows and 7 columns. Sorry, that's 7. We have 2n minus 1 rows and 2n minus 1 columns based on whatever value of n is entered. So we can move from row 1 all the way to row the number of the grid size. I'm sure you get it. Okay, so then we can have an inner for loop which will iterate over the columns. So I'll call it call equal 1, call also less than or equal to the grid size, and call plus plus, right? Good. Now we've done that. Now the next most important thing for us is determining now how do we figure out what values goes into which cell. And this is an interesting logic, okay? So now when I was thinking about this, at first I was thinking of trying to figure out a relationship between the row number and n. So between whatever row and column the value is in and n. But turns out that that's process of thinking about this is way complex, way inefficient. It's not a good way to think about it. Instead, the best way to think about it is looking at each value as if it's at a certain distance from the edge. So assuming we are considering this to be the edge, okay, and then this to be the edge, like basically boundaries. When I say edge, I mean boundaries. So let's say this is a certain wall with 4 boundaries, right? Now, what's the best way to think about this problem will be to think about each cell as being a certain distance away from the boundary. Okay, now if we're able to calculate the distance away from the boundary, there's a relationship between that distance, the number that we are printing in that cell, as well as the n that was entered by the user. Okay, so now let me give an example. For instance, if we take 2, okay, this 2 that is here, let's just consider the cell. This cell is at a distance of what from the boundary? 0. It's literally no distance away from the boundary, this side. Okay, and because of that, I can come up with an equation and say that, okay, then it means that if this 0, say n was 2, okay, it means I can say maybe something like n plus whatever distance, okay, will give me whatever is supposed to be here. Let's just see it. So let's just see something like this in the equation. But this is just a trivial way to think about it, because we are not supposed to just consider the distance from the left hand side. We're also supposed to consider the distance from the right hand side, the distance from the bottom, and the distance from the top. So for every cell, we are supposed to calculate how far it is from each border. Then based on that, we are supposed to, if we want to know the depth, how deep that cell is within this region, then what we do is that we find the minimum of those 4 values. By finding the minimum of those 4 values, you're able to determine the depth. Now, once you determine the depth, it's just simple arithmetic to determine what value is supposed to be within that layer. Because once you know the depth, which is going to be the minimum of the 4 values I just spoke about, then you can tell where the cell is, and then since you know where the cell is, you can tell what value it will be based on whatever n the person entered. I know I'm speaking a lot, but this will all make sense. So now let's go and implement that code. So we are going to have a distance, but let me call it a displacement, okay, for the left part of the grid or something like that. So the left displacement, when we look at this, the left displacement, okay, is going to be, we are looking at it from this angle, right? Okay, so the left displacement will be equal to whatever column number the cell is at minus 1. Okay, now someone might ask why. Now when we look at it, for instance, let's just consider this cell. Okay, when we just think about it, the left displacement is what? 1, because it's at a distance of 1 away from this border, this left border. Okay, now if I were to represent that mathematically using the columns, because we are dealing now in this position, okay, in this position, and in considering the direction we are looking at, we will have to consider the columns. We can't be considering sorry, did I say columns? Yes, we are supposed to be considering the column because the row is constant. Okay, now you can see here that this is column 1, and this is column 2, and this is column 3. Okay, now based on what I just explained and then what we did logically to determine that the distance is 1, we can obviously see that if you subtract 1, okay, from the column number, you are going to get the displacement from the left. And we can apply that same principle here. If we subtract 1 from this column number, we'll get 2. And 2 is exactly the displacement of this cell from this border, you see. So that is the left displacement formula. So left displacement formula is just equal to the column minus 1. Okay, and we can now do the right displacement. So what would the formula for right displacement be? So right displacement will be looking at, for right displacement, we are looking at it from this side. Okay, so now if we consider this cell, we know that it is 1 away from the left, and in this case we also know that it's 1 away from the right. So now how do we determine the equation for the right? Using n and whatever we have as a column. Okay, someone might say, oh, it could just be the same c minus 1, but no, that won't work. Why won't that work? Let me just change this grid so that you understand why I'm saying that won't work. Let's use a 3x3 grid. So if we have, let's use a 5x5 grid. We have this. Limits. Okay, so now let's consider this cell. Okay, what is its position? What is the left displacement for this cell? Right, let me write it there. It's what? It's 2. Actually, no, let's not use that. That will not help you get my point. Let's pick this cell. What's the left displacement for this cell? It's 1. Right, perfect. Because just 1 away. And if we look at the column it's on column 2. 2 minus 1, that gives us 1. Perfect. Now, what is the right displacement? You can't say it is what? C minus 1, which is what? 2 minus 1. See, that won't make sense. Okay, so the right displacement for this same cell will have a different formula. Now, when we look, we know that the grid size is 5. Okay, now what we can see is that the right displacement is what? 3. Okay, and we can see a relationship here that the grid size minus whatever the column number is gives us this. And we can experiment. We can move it to this part. Right displacement is 2. 5 minus 3 is 2 because we are on column 3. We can move it here to column 4. Right displacement becomes 1 because 5 minus 4 is 1, and it works. So meaning that the right displacement is equal to the grid size minus the column number. Okay, so that's what we are going to have. So we are going to have right displacement to be equal to the grid size minus the column number. Now this is very simple to apply in the top and bottom displacement. Okay, I'll leave that to you to figure out, but the top displacement will be equal to the rho minus 1, and the bottom displacement will be equal to the grid size minus the rho. Okay, now what we want to do is we want to find the smallest out of these 4 values that will represent our depth. Now we'll just use a function to do that. Okay, so we'll define the simple minimum function here, which will take a and b. Okay, and we're going to say if a is less than b, then return a. Okay, otherwise return b. And then we're going to call that function here. So we're going to create another variable called depth, and depth is going to be the minimum of these 4 values, which we are going to have here. So we are going to have left displacement, right displacement, top displacement, and then bottom displacement. Okay, so now that we have our depth, we can now calculate what the value is within the cell. Okay, so the value within the cell is simply going to be n minus the depth. Okay, because whatever we have here, so for instance, let's pick this and work with this. Let's work through us with this. Okay, so now this is 2. We want to calculate the depth of 2, but before we calculate the depth of 2, we have to find the left displacement, right displacement, top displacement, and bottom displacement. Okay, so for this value, what's the left displacement? It's 1. What's the right displacement? This one's 1, 2, 3. What's the top displacement? It's 1. And what's the bottom displacement? It's also 3. Okay, great. So now what's the max? Sorry, what's the mean of all this? The mean of all this is 1. Okay, so now I'm saying that if we take whatever was entered as n, which in this case was 3, and we subtract the depth, which is 1, we are going to get the value which is supposed to be in that cell, which we can see here, 2. So that's what we are going to implement. So we are going to have the value. So we are just going to print it directly. Okay. We are going to print n minus the depths that we calculated. And they said the numbers are separated with space, so we are going to bring a space here. Okay. Then since we are supposed to print it as a grid, once we print for the first row, okay, we are supposed to move to a new line and print for the second row. So we are going to print a new line here. And this does it. So let's run our code first and see if this works. Perfect, it works. You can submit it now and it passes all the test cases. Amazed. So if there's anything you don't understand, just take your time to go through the video once again. If there are any questions, you can leave them down in the comment section below and I'll be glad to answer them. Thank you. Have a great day.